rather than this superb Concord, you just use your own STL. So this one should remind you something. And then what happens? You can use it to make your own simulation. This is not fancy. It's not so difficult. I will show you. You just have to go here on the file. We have many examples. So you have one video for the Concord. You have Cessna 172. You have a video about Formula One and 747. What happens is you just have to search in the code. Here we are in the Boeing 747, and you just have to plug your own STL file into the code. Basically, trying to make your own first simulation is quite simple. So for example, actually I am in the Concord, so I put my own STL file. You can use the radial fan. There are many examples and many videos that are linked. There is also aerodynamics of a curve, space shuttles, Cessna 172. And in this video, I'm gonna to help you to understand what to do, what to set up. And I will talk to you a little about LBM. Let's come back to the site of this young genius, Dr. Morris, make some development for LBM method. I'm going to explain you this later. And he pretends that it's faster than most other LBM code. You can, of course, generate some complex simulation. So typically, type of simulation is, wind between buildings into a city. So I invite you to discover his site, but now let's try to begin. So you have two important steps, and if we are watching carefully the documentation, you have first to download the source code, and secondly, this source code should be compiled with the Visual Studio community software. In case you are using Windows, because you also simply can directly use Linux, Mac OS, or Android. If, like me, you are using a computer that works with Windows, you first need to type, for example, feedx 3D GitHub, and you will find out the GitHub folder. Here you have the documentation. Just need to open the documentation. I recommend to open this one first. How to download the code? You go on the right of the window and you have the latest version. We're gonna have to open this. And the code is here. So it's not difficult. You download the code, you unzip the code. It looks like this. This is the code. Then you have the code, you have to download Visual Studio Community. Now the problem is the link is sending you to the German site, and I don't understand any German. So I have to download the French one because I absolutely cannot retrieve, unfortunately, the English one. And then you go here. And here we are. You have three versions: Visual Studio Community, Professional, and Enterprise. So you can start the download of this one. Click yes. And I want to come back here because in the documentation you have three important extensions to add. It's only when you have started the installation of Visual Studio Community that you can tick off these three extensions. So you will have to find here in the individual component, and among this long list, and that's the problem, the most difficult is to find out the three that you need. And then it's done. Simply working, we will see how to start. It's quite easy. When you have installed everything, you need to go to your folder. So this is my folder, and you will start Visual Studio by using this. You double click on this file, this one. You make a double click, and now Microsoft's Visual Studio has started. We have on the right the last file that I have opened, and on the left tab the second one I have opened. To start definitively the application, we are making a push with the left click button of the mouse on Windows Debugger, simply. And now the application has started. The application has executed the specific code. If I press hash, I have the contextual menu. I will escape to stop everything right now. And we can see here the application, I would say, and some information. We just need to come back on the setup, and you have many examples that are simply the summary of one of the video. For example, if you like planes, you will go below. So you have here the Concorde, you have here the Boeing 747. So you can see the difference. Everything is green, everything is disallowed because there is a slash and there is a star here. I have removed the star and the slash. It simply allowed the code to be run, and what we have seen was exactly this code. You will simply try to find your way between the different parameters to implement the parameters you like and also the file you like. So for example, it is said to open a folder, and the folder is in the bin, and you have to create this STL yourself. In this STL, you will put any STL file you would like. It works only with binary STL, and you put every model you would like to download. And therefore, you will put the exact name of the file you want. But one thing very important to know is that each specific example requires some special extensions, and those extensions are named one by one here. So in this case, we have this one, second one here, subgrid. Let's see what happened. Interactive graphics or graphics. And you will ask me how I could open and put on this extension. So you have to open another file, which is in the source. And in the source, so you have the main files. And the name of this file is define.hpp. I have already opened it. It contains all the necessary extension, and then you have to liberate those files. So you just have to remove the double slash, and therefore the extension will be on. So you can see that I have opened the one that I needed. So this one, for example, is actually active. This one is all time needed. This one, it's setting the forces. This could be the drag or the lift. Subgrid is when you have different components, different parts in your object. And for each example, you have to check out if the extension is activated or not. Where to find the setup.cpp? The setup.cpp is on the source folder, and this is this one. So it's already opened. So I come back here. And that's the most important one. That's different example for different kind of work. Just watch each of the video on the site and you will have an idea what's going on. And also just open the documentation. The parameters, you have different kind of example with different kind of parameters. So it should help you in the syntax. Of course, I will tell you right now that I'm not at all a specialist of C++.
So to tell you a little more about the Lattice Boltzmann method, it's a different approach for what I have understood. So this is more about flow and particle that are sent with a stream against some specific physical structure. And you can find more explanation here on SimScale, and you will have a more comprehensive grid of what it looks like, the LBM, which is the abbreviation of the Lattice Boltzmann method. For more information, just go to SimScale. It's well explained. This LBM method is especially useful when we come along 3D structure and interaction between different physical forms. So you can think about the interaction of Formula 1. It's a really complex geometry, and it's very difficult to predict the behavior through the classical computational fluid dynamics, the Navier-Stokes one, for example.
So little things about the resolution. Here you will put the number of your GPU megabyte. So for example, I have a little more than 4 gigabyte. The simulation is close to start, and when I will shut off, I will know here which type of device I have. It's an RTX 3050, and I have 4095 megabyte of GPU. So of course I need to use a little less, and I put 4000. So if you are blocked and nothing work, you have to modify this number accordingly to your GPU card. So that's the first tip I can give you. Another stuff that I found very interesting in the Mercedes Formula 1 car is the possibility, of course, that you can make things rotating like a propeller, but here we can see that we have some front wheel and some back wheel, and they are put in two different spaces, and the body of the car is put in a third grid. It's quite interesting to have different spaces where you can put some different objects and probably assign them different position and different function.
Among the stuff that could interest you in the tab discussion in the Fluid X3D GitHub, I found out that rather than to use the GPU, you can rather use CPU. Dr. Moritz answered to this question by telling that you can install the OpenCL CPU runtime, and you can simply, with this command line, use the CPU rather than the GPU. So it can broaden your grid resolution probably accordingly to your memory. I would like to introduce you to OpenLB, and why I want to introduce you to this one, it's because Dr. Moritz is more the one guy, one shot, one project. He do this like hobby, purely and simply it lacks of documentation. I don't know how to use a different function. I don't know how to write the code. Of course, I'm not a C++ guy developer. Of course, maybe the C++ guy developer could do such a thing, but not me. This project has started 17 years ago. It's like consortiums. Therefore, you have some maintenance, a lot of updates, documentation. You have a YouTube channel. You have some support. You have a forum. You have cases. It works on Windows, it works on Ubuntu, on macOS. So it's a real more mature project. For example, this is the user guide documentation. There is a developer guide documentation. We have technical reports, some different articles, some cases, of course. So I think that if you would like to invest some time in the LBM solutions, I think this one is really worth off.
So in Fusion 360, I remind you how to get an STL file, a binary one. So you have to go on the 3D print menu, on the main menu, and now you make your selection. So I'm selecting this one. You choose your unit. Of course, you want the binary, which is a compressed sort of file rather than the classical STL. And then you choose your refinement. So I think that you would like to have at least a medium or high one. Let's see what could be the preview mesh. Yeah, so that looks good. Let's see in the medium case. It's quite final, so I will keep the medium for this one. So here we give the name of the file. So we say CFD, and that's what we want. And we want to save this on the computer, of course, but I want to change the folder because I want to go to the CFD, and CFD is here, and this one, we go to the source and we drop this in the STL folder, and everything will be fine. So I'm happy with the result.